Okay, so let's take a look at another example covering distance from line to a point. And the problem that we have now, we've got a map. So you can see a map here. We've got a ship which is going away from point A. This direction vector 3, 4 gives us the direction at which the boat's sailing. Point R is the point at which the boat is at any point in time. And there you go. So you've got our origin here, point A, point B, and we know that the speed of this boat is 10 kilometers per hour. All distances here are shown in kilometers. So let's do it. So letter A, write an expression for the position of the ship in terms of t, the number of hours, numbers of t, which is the number of hours after leaving port A. So we're looking for some expression for this point, r, x, y. Well, the first thing that we have to notice is that we know the direction vector for this point, right? For this line, for any point in this line. However, this vector that we know, I'll call simply vector A, because that's not quite the direction vector that we need. We're going to get something that's proportional to that. Let's take a look. So I know that my vector that gives me this direction is 3, 4. And if I take the magnitude of this vector, so if I was moving at this rate, following this direction vector, I would have a magnitude of root of 3 squared plus 4 squared. This is a Pythagorean triangle, so it's fairly simple to see that this is 5. Right now, since this is 5, this would be 5 kilometers per hour. That would be the speed at which my boat would be sailing, or my ship would be sailing, if it was following exactly this vector. However, I know that my boat is sailing at twice as fast. So my direction vector is actually twice that. So it would be 2, 3, 4. Or simply 6, 8. Simple, right? So that's our direction vector. If we want to write an expression in terms of t, then we just write our vector equation. So x and y, which is a point in this, any point, we're basically finding point r in terms of time. So x and y, we have our arbitrary points. So at time 0, I begin at -8 and 3. If time was 0, that would be my point. However, I'm moving, so I've got something here, 6 and 8. And after each hour, that's how much I'm going to increase. And t is a real number, right? I may have 0.1, I may have 0. If it's 0, again, x and y will be -8 and oh, this is positive. So -8 and 3, right? If my time is 1, then I'll add 6 to x, that's going to be -2, and I'll add 8. You got it? So just for example, when time is 0, I'll get simply my point r will be -8 and 3. That would be the position where my point would be. At t equals 1, after 1 hour, I would have a new position of -8 plus 6, so that's -2 kilometers, and 3 plus 8, 11. So we could, in fact, for example, find the point. -2, this is -8, this is 0. So we have each 2 squares would be 2. So it would be somewhere around here, x and y, 11. So that would be probably it. That would be this, it would probably be this point here. Right? There you go. And we could keep doing this if we want to find the position at any time. Now, letter B, and well, there we go. So we can find, we've got an equation, our vector equation, to find the position of this boat or this ship at any point in time. Now find the time when the ship is closest to port P, which is at point 10, 2. So let's draw this. I've got this line, which is my line AR, right? That's the line that we have this equation. That's the line that describes where my ship's going. This is point A. And I've got another point here, which is point P. If I want to find the closest, I should get the line which is perpendicular to that line, right? So I'm going to have two vectors which are perpendicular here. So I just need to get this direction vector, which is the direction vector of my vector equation. And well, if I call this point R, let's do AR. I know that AR, RP or PR, if they are perpendicular, this has to be 0, right? Because AR is perpendicular to PR. If this is the shortest distance, they have to be perpendicular. Now, if they are perpendicular, I can take the dot product and that's going to be 0. So what would be AR? What would be any line AR? So I have to find here two vectors, right? What would be vector PR? Now, vector AR, that's simple. Vector AR is our direction vector. So we can either take 3, 4 or 6, 8. It doesn't matter because they're just proportional. So when we do the dot product, there will be things multiplying, but since this is all equal to 0, we can simplify. So what I would suggest, just take the simplest vector, so you multiply by smaller numbers, and then you're less prone to committing mistakes. Now PR is slightly different, because we're going from point P, which we know the coordinates, up to point R, which we were given an equation. So point PR is in fact coordinates of point R minus coordinates of point P, right? So PR, coordinates of point R, so let's just XR minus XP, and YR minus YP. That's how we find a vector when we have 2 points, because this equation is going to give us 2 points at the end, and we know the 2 points, the coordinates of point P. So 2 coordinates, sorry. So if we do that, XR, well, is given by our equation. So x of r is negative 8 plus 6t. What's x of p? Well, that's coordinate of p. So x of p is 10, so this is minus 10. Now the second one here, y of r is our coordinate here of point r. So 3 plus 8t. Minus yp, so minus coordinate of point, y coordinate of point P, which is 2. There we go. Now, when we do this dot product now, so AR, which we can just denote as B, right? PR, and now we can take the dot product. So we simply multiply x coordinates and add with y coordinates. If those vectors were 3-dimensional, then you would do the same thing for the z coordinate. But here it's only 2D, so it's simpler. So there we go. So B here, the first is going to be 3. So 3 times negative 8 plus, let's just work those numbers here before. So negative 18 plus 16, right? Plus 3 plus 8t here, 3 minus 2, that's 1, so 1, and that's multiplied by 4, so 1 plus 8. t. Right? So far so good. So if we work those numbers in here, we're gonna find, so negative 54 plus 18t plus 4 plus 24, oh sorry, 32t, right? 4 times 8. If we work that out, and that's all equal to 0, right? We cannot forget that. So 54, negative 54 plus 4, that's 50, negative 50, plus 50t. So we basically find that t is equal to 1 hour. And that would be our answer. So the ship is closest to port P 1 hour after leaving point A.